Okay, so we're all living through this incredible AI revolution, right? But what if I told you there's a hidden cost? A massive challenge that could bring the whole thing to a grinding halt. And it all comes down to one thing: power. We've all seen what AI can do. It can write a poem, it can speed up scientific research. But here's a wilder question for you: can it crash a power grid? I know it sounds dramatic, but this question gets right to the heart of a massive, hidden challenge we're facing. Could the very technology that's shaping our future accidentally break the system that powers it all? Well, the answer is a lot more complicated than you'd think.
To really understand why, we first have to wrap our heads around the sheer scale of what's happening. We are smack in the middle of a colossal AI power surge.
I mean, the amount of electricity needed to train and run these advanced AIs it's growing exponentially. But here's the real kicker. This isn't just about building more power plants. The way AI uses power, the very nature of this demand, is completely different from anything our electrical grids were ever designed to handle.
And that fundamental difference, well, it's leading us straight into what experts are now calling a stability crisis for the entire grid. This is the big, hidden problem that could literally stop the AI revolution in its tracks. So I was looking at this talk from Dr. Hong-Soo Go at the World Future Energy Summit, and he just nailed it. The real danger isn't the total amount of energy AI uses over a whole day. Nope. It's how that energy is used from one second to the next. The demand is unbelievably volatile. We're talking dangerous spikes and sudden dips. Think about it like this. For 100 years, grid operators have planned for predictable demand. Like a steady, constant river of power. It's easy to manage. But AI data centers? Whoa. They are a completely different beast. Their power needs are like a sudden, totally unpredictable flash flood, spiking up and dropping off in the blink of an eye.
Okay, so you might be thinking, so what? It's just a spike in demand, right? Big deal. Well, not exactly. Why is this flash flood of energy so incredibly dangerous for the delicate ecosystem of our power grid?
See, our grid depends on this constant, incredibly delicate balance between the power being supplied and the power being used. These rapid swings from AI can throw that balance into complete chaos, and that can destabilize the entire system. And the worst-case scenario here? We're talking cascading failures, widespread blackouts, and even physical damage to critical, expensive equipment. Plus, all this volatility makes it way, way harder to bring renewables like solar and wind into the mix.
So that's the scary part. We have a huge problem. But thankfully, engineers are developing an equally powerful solution. And it's this really elegant concept that basically acts like a digital guardian for the grid.
Let's meet the hero of our story, the Grid-Forming Battery Energy Storage System, or BSS for short. Now, don't just think of this as a big backup battery. It's way smarter than that. It's an incredibly fast-acting shock absorber that doesn't just react to the grid, it proactively generates its own perfect, clean electrical signal. It's kind of like a conductor for an orchestra, setting a perfect, stable tempo for the entire grid, no matter how chaotic the demand gets.
And Dr. Go, the expert I mentioned earlier, he has the perfect analogy for this. He calls it a power firewall. And it makes total sense, right? Just like a computer firewall protects your network from dangerous traffic, this BESS sits between the chaotic AI data center and the stable grid, buffering all those dangerous power surges.
The whole process is actually incredibly simple and effective. So step 1, the AI data center suddenly demands a massive amount of power. Step 2, the BES responds in milliseconds, instantly supplying that power from the energy it has stored. And step 3, from the grid's perspective, absolutely nothing happened. All it sees is a smooth, stable load because it's completely shielded from all that chaos.
Now, this is so much more than just a clever piece of technology. This really represents a fundamental shift in how we need to think about building the infrastructure for our AI-powered future.
For years, we've pretty much seen these big battery systems as simple backup power. They were just a safety net, something you only use when the main power goes out. They were a supporting player, at best. But that view? It's totally obsolete now. The new way of thinking, the new paradigm, is that BESS is critical infrastructure. It's just as essential to an AI data center as the servers themselves. It's not an add-on, it's a foundational, non-negotiable component. And the benefits of thinking this way are huge. For tech companies, it means you can build new data centers and get your AI services out there way faster without waiting years for massive grid upgrades. For all of us, the grid itself becomes more stable and more resilient. And here's the most exciting part.
This is what finally unlocks the dream of truly sustainable, zero-carbon data centers, powered entirely by renewables that are balanced by these intelligent batteries. So let's bring this all together. What does this really mean for the future, for both AI and for energy? Ultimately, it comes down to this. You simply can't power the technology of tomorrow with the grid of yesterday. It's not going to work. The AI revolution absolutely demands an energy revolution. And the solution isn't just about generating more power, it's about building a smarter, more flexible, and more resilient grid, with technologies like grid-forming BESS right at its very core. And that really leaves us with one final critical question. We're building these machines with incredible intelligence, AIs that can learn and adapt every single second. So the real challenge is, how do we build a power grid that's just as intelligent? That's the question that's going to define the next era of technology.